It's an experiment, any process with uncertain results that can be repeated. Okay, the being repeated part is important. If it's only something that you can just do once and then you're done, it's not really an experiment. You have to be able to repeat it and continue to test the likelihood of events. So empirical probability, also called experimental probability. So both of these types of probabilities that we're talking about have two names. It's not that funny. Okay, so classical and theoretical probability mean the same thing. Empirical and experimental probability mean the same thing. So you got to be okay with both names for both of them. But experimental or empirical probability is probability that's calculated based only on the results of an experiment. Okay, so empirical and experimental probability, like if we're flipping a coin, this type of probability doesn't matter, or it doesn't care that it should be 50-50. You would just take however many times you flipped the heads, and calculate your probability based off of that, what actually happened in your experiment, not what should happen. So to do this empirical approach, we've actually technically already did this back when we were doing like histograms and relative frequency tables, because empirical probability is really just the relative frequency of that event occurring. So the probability of event E is approximately equal to, because empirical probability, experimental probability is an approximation of the probability of that event, since it's just based on a limited number of experiments. But it's approximately equal to the relative frequency of event E, which just means you would take the number of times event E occurred when you were doing your experiment. Number of times E occurred, and you would divide that by the total number of trials, or the total number of times you did your experiment. Okay, so again, empirical probability is essentially just another way to tell you the results of an experiment. Okay, so the probability obtained using the empirical approach is approximate, because different runs of the experiment could lead to different estimates of that probability. So when we do the activities, when we do the project today, you guys are going to see that even though you're all doing the same experiments, you're going to be getting different results from the other people doing it. And that's why empirical probability, ladies, that's why empirical probability is an approximation, because you can get different results based on what experiment you're doing. Okay. So example 1, this is what we're going to be doing for the activity today and tomorrow, where you are first going to be asked to determine the classical probability or the theoretical probability, so what should happen. Then you're going to do an experiment, calculate some experimental probabilities, and then compare. So example 1, we want to determine the classical probability of rolling a 4 on a fair die. So how many ways can we roll a 4 on a die? Once. So probability of rolling a 4 is going to be 1 over 6, because there's 6 total possible outcomes. And for this activity, it's going to be helpful if you convert your probabilities into either decimals or percents, because it will make it easier to compare with the experimental probability. So 1 divided by 6, what is that as a decimal? You just do 1 divided by 6 in your calculator. Somebody? What? 0.16. 0.17 if we're rounding. Okay, and then we have the classical probability for rolling a 6. So the probability of rolling a 6. How many ways can you roll a 6? 1 way. And how many total possible outcomes are there? 6. When you roll a die, there's 6 possible outcomes. 1, 2, 3, 4, 5, or 6. So that also equals 0.17. Okay, so this is the classical probability, theoretically what should happen, what the probability should be. And then let's say we conducted our experiment where we rolled a die 100 times. So this means we rolled a 1 18 times, we rolled a 2 15 times, we rolled a 3 17 times, etc. So now we're going to use these numbers to calculate the empirical or experimental probability. Okay, so when we're using a table, this is what we use for the empirical approach. Any numbers you use, you got to get from this table. We don't care that there's 6 possible outcomes. We don't care that there's 1 1 on a die. We just care about the results of the experiment. So calculating the empirical probability of rolling a 4. This would be the number of times we rolled a 4. Over the total number of trials. So based on our table here, we rolled a 4 13 times. And we did the experiment 100 times. Or if you add up all the frequencies, that should give you 100 because it's the total number of times we did the experiment. Okay, and then again, writing this fraction as a decimal will make it easier to compare the probability. So this is going to be 0.13, which is kind of close, but it is not exactly the same as the classical probability, which is what's going to happen. Okay, that's why empirical probabilities are just approximations. They give you an idea, but it's not exact. Okay, and so letter D, using the empirical approach, approximate the probability of rolling a 6. So again, it's the empirical approach, so any numbers we put in our fractions have to be from this table. So we rolled a 6 22 times, so it'd be 22, over the total number of times we did the experiment, which is 100. And that gives us 0.22. Okay, which is a little bit more than what theoretically we said should happen. Okay, do you guys have any questions about the difference between classical and experimental probability? Okay, so one last thing here, this law of large numbers. This just says as the number of repetitions of a probability experiment increases, the proportion with which a certain outcome is observed gets closer to the probability of the outcome. So generally, what that means is the more times you do an experiment, the closer your experimental probability will get to your theoretical probability. So really what that means is if you only rolled a die like 3 times, those results are not going to be very close to the classical probability of rolling a die for each number. But when we do it 100 times, our probabilities that we got, though they weren't exact, they were kind of close to what should happen. So just the more times you do an experiment, the closer experimental probability will get to what should happen, to that classical probability.